As you may know, astrophysical observations over the last few years have indicated that the vast majority of the universe is in a form that's not apparent to us except through its gravitational interactions. And this invisible universe comes in two forms. One is termed dark energy, and it's still quite a mysterious anti-gravity-like effect. And the other is termed dark matter. And for several reasons, we believe that dark matter is, in fact, a type of particle. We're not for sure of this, but we believe that's the case. And so many groups around the world are in a race to try and discover dark matter interactions in the laboratory. Now, this is very difficult because dark matter, if it's in a particulate form, is very, very weakly interacting. We certainly have seen no sign of it yet, and so we have to build ever more sophisticated detectors, and they need to be more and more sensitive to discover the whisper traces of this dark matter coming from the cosmos. We're also trying to produce it in the high-energy collisions that occur here at Fermilab in its large Tevatron machine, which is a matter-antimatter collider at 2 trillion volts, and of course the new machine just commissioning in France and Switzerland called the LHC, the Large Hadron Collider, which is more energetic than Fermilab's Tevatron. And those teams in both of those accelerators are racing to discover any traces of dark matter that may be produced in these energetic collisions, much like they were produced in the early universe. Meanwhile, many groups around the world, 15 or 20 or so, are racing to see if they can detect dark matter directly, the dark matter that we think exists all around us and is penetrating us all the time. And to be more and more sensitive to the very, very weak interactions of dark matter, almost all of these groups go deep underground in mines to get away from the radiation on the surface, mostly induced by cosmic rays. So it turns out that Fermilab is involved in several of these dark matter searches, and the most sensitive one in the world is in fact one that is managed by Fermilab in collaboration with many university groups. And this experiment is called cryogenic dark matter search. And so Carl, my brother Carl, and myself were interested in the artistic aspects of this experiment, and so we've developed a device that takes the data coming in on the detector and represents it in an artistic sense, both visually and with musical notes. And so I'll be showing you a model of the cryogenic dark matter search experiment whose data is driving a visual and audible display.